Hello, welcome back to my channel. In this video, I am going to explain about Leontief's input-output model in an economic system using linear algebra. So let us see the effective matrix algebra in problem solving in the economic system. Matrix algebra has proved effective in analyzing problems concerning the input and output of an economic system. The model discussed here is Leontief's input-output model, which he created and published in the year 1936. He was awarded the Nobel Prize for his work in economics. It is a model for the whole country or a region. In this model, there are n number of industries producing n different products such that the input will be equal to the output, or we can also say the consumption is equal to the production. Now let's see the input-output matrix. Let us assume that we have an economic system, and this system has got n different industries. Say those industries be I1, I2, I3, etc. In. Each of these industries have got input needs. The input needs can be raw materials, utilities, like that, and the outputs like finished products. And we call this Dij to be the amount of output the jth industry needs from the ith industry. Maybe the industry 1 will need the things from the same industry. It will use its own product. But Dij will be the amount of output the jth industry needs from the ith industry to produce 1 unit of output per year. Suppose if I am saying D11, D11 is the amount of output the first industry needs from itself to produce 1 unit of output per year. The same way D22 will be the amount of output the second industry needs from the second industry itself to produce 1 unit of output per year. If I call D13, D13 will be the amount of output the first industry needs from the third industry to produce 1 unit of output per year. And this sum of all these Dij, since we take this as a probability or a fraction, this total must lie between 0 and 1. It is just like the stochastic matrix. The sum of these entries in this column should be less than or equal to 1. It cannot exceed the 1. It applies the probability rules. So in this case, the output-input matrix will be denoted by the letter D, where the supplier input for the different industries I1, I2, I3 are given, and the user output is also there. I1, I for the different industries are there, and these D1, D2, D3, which are representing the rows and columns here in the input-output matrix, will represent the amount of output the jth industry needs from the ith industry to produce 1 unit of output per year. So to understand this model, let us consider an example here. In this, let us consider a system consisting of 3 industries. The industries are electricity, water, and coal. It says the production of 1 unit of electricity requires 0.5 units of itself because it is needed to produce 1 unit of its own product, and 0.25 units of water and 0.25 units of coal. The same way, the production of 1 unit of water requires 0.1 units of electricity, 0.6 units of itself, and 0 units of coal. The production of 1 unit of coal requires 0.2 units of electricity, 0.15 units of water, and zero point 0.5 units of itself. Now we are asked to find the input-output matrix for the system. So let us create an input-output matrix for the system where the details are given. So the column entry shows the amount each industry requires from the other industry. The first column, first row will be the amount the department electricity requires from itself. And the second one, 0.1, will be the amount the electricity department requires from the water department, like that. So we can create the matrix here. The row entry shows the amount each industry supplies to the other and to itself. So I think this matrix is easily obtained because we know how to represent the rows and columns. The rows and columns represents the number required from each industry to the other. Let us explain the Leontief's input-output model. Let Xi denote the output of the ith industry, and if the system is closed, meaning that it sells its products only to industries within the system, as in the above example what I explained, then the total output of the ith industry is given by this linear equation. We call this a system to be closed. The system is closed, meaning that it sells its product only to industries within the system. There is no external requirement here. There is no external demand here. It sells within itself, in which case your Xi will be di1 x1 plus di2 x2 plus etc. din xn. You multiply the rows and the column. The same way for all those n values, you can have x1, x2, x3 in terms of d's and x's. Apart from this closed system, we can also talk about the open system. If there is an external demand for this industry's product, let us call that a demand as E. In this case, we have this n system of simultaneous equations, x1, x2, x3, where that E1, E2, E3 are added, where this EI represents the external demand for the ith industry's product. If there is a demand for this product, external demand, then we may have this linear equation of matrix X, which is equal to dx plus E. D is the output input matrix what we created when it is closed, plus the external matrix, demand matrix. So X will be dx plus E, where X is called the output matrix. Your X only is your output matrix. E is the external demand matrix. Now our aim is to solve for X. How are we going to solve this X? See, since it is a matrix form, you cannot simply solve for X using simple algebra. We have to make use of matrix algebra. So your left hand side is not X, it is 1x, where 1 is can be taken as the identity matrix I. So I have Ix equal to dx plus E, or Ix minus dx equal to E. From this, if I pull x outside, then I have x times I minus d equal to x E, or I can say x will be I minus d inverse multiplied by E, as we saw in linear equations. So this X will be the solution of the matrix, which is the output matrix. So from this, you can easily get the value for X. So how are we going to get the value for X? X will be I minus D. I is the identity matrix. If it is a 2 by 2 matrix, your I will be of order 2. If D is a 4 by 4 matrix, your I will be a matrix of order 4. Let's see an example to understand the Leontief's input-output model. So we are trying to solve the output matrix X, where X satisfies this equation, matrix equation, X equal to dx plus E, or your I minus D equal to X times X equal to E, or in other words, X will be the inverse of I minus D times E. So let us take that there are three industries A, B, C. You have inputs and outputs, and the matrix is given. Your D, the matrix D, will be the input-output matrix, and E, the external demand, is also given. So if I'm trying to find X, where X is my output matrix, I have to solve for I minus D, where I is the unit matrix, D is 0.1, I is a unit matrix, so it is 1, 0, 0, 0, 1, 0, 0, 0, 1. So you can easily get the value for I minus D inverse times this will give you the last matrix what we find here, and that will be the solution. Let us explain this clearly here. If I minus D times X is equal to E, then X will be the inverse of this. So how are we going to find the inverse of this? You can just enter that in your graphing calculator, take the inverse, multiply by the demand matrix. That will give you the final answer. The answer will be the output for industry A, industry B, and industry C. So this is how the Leontief's input-output model are used in economic system. So here the matrix algebra is used to get the production results. So in this video we saw the Leontief's input-output model using linear algebra. Hope you enjoyed this great American economics published work for his Nobel Prize. Thank you for listening. Thank you for watching.